This video will explore a defect telemetry and MTTR optimization engineering playbook designed for Azure DevOps Analytics and Power BI. We will detail the end-to-end data pipeline, from raw telemetry input to analytics and reporting. The "black box defect lifecycle" means engineering lacks crucial telemetry. We see a mean time to remediate, or MTTR, of 65 days for critical severity vulnerabilities. Roughly 33% of vulnerabilities are high or critical, and adversaries exploit a discovered vulnerability within an average of 15 days. Traditional Agile reporting with point-in-time queries only reveals the current state, missing stagnation. To reduce the 65-day MTTR, we need continuous telemetry. This involves historical time series data to explicitly measure state stagnation and transition from reactive to predictive optimization. Our solution is the Snapshot Fact Table data model. Unlike transactional fact tables, snapshot fact tables are dense, recording a row regardless of activity. This allows for native time-in-state calculation via daily sampling, crucial for accurate MTTR tracking. The daily snapshot grain provides an X-ray view. By forcing ADO to extract a flat data row every 24 hours, we generate a dense data set. A bug open for 5 days generates 5 rows, which allows for simple counting to determine the exact time in state. The engine for this solution is Azure DevOps Analytics views. These views offer simplified, flat list extraction of Azure Board's work item data optimized for Power BI. Note the scope constraints and the requirement for basic user access and view analytics permissions. When blueprinting the analytics view, it's crucial to filter by bug type to reduce the initial dataset. Select key fields like work item ID, state, and change date, and set the granularity to daily over a rolling period. Excluding work items completed before a start date drastically reduces the data load. Power BI's OData connector has a strict 10-minute timeout, often causing refresh failures in large environments. The fix is to append a duration parameter in the advanced query editor to increase the timeout to 2 hours. Also, avoid including rich text fields to minimize data bloat. The Power BI implementation pipeline starts with Azure DevOps, providing raw data. The Analytics view generates daily snapshots. The Power BI data connector pulls this data with the timeout defense. Power Query handles data modeling, and the DAX engine executes calculations for state duration and MTTR. DAX Playbook 1 focuses on the time foundation. The date previous column maps the previous interval for each row. The date diff in days column calculates the number of days between the current and previous date, accounting for missing weekend data. DAX Playbook 2 addresses state context. Is last day in state identifies the final day a work item resided in a state, essential for accurate aggregation. State time in days sums the time spent in a state, even with transitions, tracking cumulative time. DAX Playbook 3 tracks zombie defects, which are bugs that bounce back to development after being marked resolved. The state previous and state changed count columns help quantify process friction and the time penalty of rework. DAX Playbook 4 provides the ultimate MTTR measure. The measure filters the dataset to evaluate only the final resolution state. This provides a mathematically precise MTTR, accounting for all state changes and historical context, immune to live query blind spots. The defect telemetry dashboard shows the current active volume and the predictive flow trend, tracking velocity improvement. Bottleneck identification immediately highlights hidden friction, such as triage taking longer than actual development time. For governance, configure intelligent refresh schedules, limiting Power BI to a maximum of twice daily. Enforce a data minimization policy, prohibiting rich text in the analytics view. Restrict Power BI workspace edit access to DevOps administrators, distributing the final output via a read-only Power BI app.